Hello, Model 3. Today we have the third lesson on Unit 2, Radioactivity and Nuclear Energy. First of all, let's start with nuclear energy. You studied before the atomic structure, and already you know that the atom consists of positive nucleus in the center and negative electrons rotate around it and energy levels. And inside this nucleus we have protons, positive protons, and neutral neutrons. Look, all protons are positive, so there is a repulsion force between them. But we have a kind of attraction force between protons and neutrons. This force is called the nuclear binding forces. They are the forces that are necessary to bind the nucleus components together and overcome the repulsion force that are present between the positively charged protons and each other. And you must know that the nuclear binding force are considered as the source of the source that provide the atom with a huge energy, which is called the nuclear energy. So the atom's nucleus is considered as the energy store. Now with the radioactivity phenomena. This phenomenon discovered by French scientist Henri Becquerel. As he discovered the emission of unseen invisible rays from uranium element. These rays have the ability to penetrate solid objects. So, after that, they named these elements like uranium by radioactive elements, and this phenomena by radioactivity phenomena. So, what is the reason behind this invisible radiations? The reason that the nucleus is unstable because the number of neutrons inside it is greater than or more than the number required for its stability. So when the number of neutrons increases, the atom becomes unstable due to its excess energy. So these elements are called what? Radioactive elements. They are unstable elements, unlike the rest elements in the modern periodic table. So radioactive elements, they are elements whose atoms nuclei contain a number of neutrons more than the number required for its stability, like radium, selenium, zirconium, uranium, rubidium, polonium, and cesium. And to reach stability, these atoms must radiate invisible radiation like alpha particle, gamma radiation, spontaneously, automatically, just to get rid of the extra energy to reach what? Stability. And this phenomena is called radioactivity phenomena or natural radioactivity. So natural radioactivity, it's the spontaneous decay of the atom nuclei of some radioactive elements that are present in nature in atom to achieve a more stable composition. But what about the artificial radioactivity? That was natural radioactivity. Elements do this spontaneously, but we can do this artificially. So this is called artificial radioactivity. And we have two types of artificial radioactivity. Can be controlled and cannot be controlled. The type which can be controlled is done inside nuclear reactors and, of course, for safe purposes. While that cannot be controlled, of course, is done in nuclear bombs and used in military uses. So artificial radioactivity, it's the radiation or nuclear energy that is either released during nuclear reactions or nuclear bombs.